Your AI assistant just ran a ransomware attack in 31 seconds while you were at lunch. This isn't some theoretical model or a white paper simulation. This is a real attack that actually occurred in the wild. It exploited real credentials in a production database before a human could even open the alert.
31 seconds. I want you to really think about that terrifying reality. Just 31 seconds is all it took. The structural problem we're facing today is that the timeline of an attack has violently collapsed. If an adversary compromises your environment, you no longer have hours or even minutes to react. The execution window is now literally measured in seconds.
Okay, let's dive into this. Section 1. 31 seconds to extortion, the first AI-run ransomware.
So, on July 1, 2026, the Sysdig threat research team disclosed a truly terrifying milestone, JADEPUFFER. It's the first fully documented case of an autonomous AI agent running a ransomware attack from initial access all the way through to an extortion demand with absolutely no human operator involved at any step. The agent moved entirely at machine speed. It didn't pause to read documentation, it didn't take a coffee break, and it certainly didn't wait for a human to hit enter.
Moving on to Section 2, Anatomy of Machine Speed. No fancy tricks.
Let's move to and see how this builds. Here is the specific sequence of the JADEPUFFER exploit chain. First, it breached an unpatched Langflow server. Second, it located and harvested default keys from MinIO and Nacos. Third, it used those keys to forge authentication tokens. And finally, it pivoted to encrypt the production database.
The truly scary part about JADEPUFFER isn't its so-called intelligence. It wasn't using a highly sophisticated algorithmic logic to crack encryption, it just relied on completely mundane, everyday exploits. Just look at how incredibly basic these ingredients are. The initial access, a missing authentication flaw in Langflow, specifically CVE 2025-3248, that had actually been patched over a year prior. From there, the agent found a MinIO object storage server using a default login that was literally just MinIO admin. Then it harvested root-level MySQL credentials that were just sitting right there in the environment, forged a JSON web token against a default signing key, and used AES_encrypt to lock up 1,342 Nacos configuration entries. At one point, an exploit step actually failed, but the agent diagnosed the failure and self-corrected in that exact same 31-second window. Again, no fancy 0 days here, it just did what a human would do, found real keys, and used them at lightning speed.
Which brings us to Section 3, the missing human bottleneck, or removing the safety margin.
The bottleneck that used to provide us with a rough safety margin is completely gone. Historically, even if a system had a vulnerability, a human attacker still had to manually poke around, find the keys, test them, and execute the attack. That manual trial and error bought defenders precious time. Removing that human bottleneck is what makes the presence of real master keys in an execution context so utterly fatal. Human operators are slower. They're prone to delays. But AI agents, they execute at machine speed. They self-correct without needing to step away from the keyboard. When an agent like JADEPUFFER drops into an environment and immediately finds fully powered credentials, the attack is practically over before your security team's pages even start buzzing.
Now, what's really interesting about this slide is how the broader industry is validating this exact structural gap. Shane Barney, the CISO over at Keeper Security, looked at the JADEPUFFER disclosure and noted that every single entry point traced back to a failure of credential governance. Secrets were stored where they should not be, default credentials were left completely unchanged, privileged accounts were wide open with zero-scope limited controls. This is an independent security executive confirming exactly what we're looking at here. The credentials were real, and they were left right out in the open.
Section 4. Bounding the blast radius and the structural flaw.
We have to pivot sharply to the root cause here, because human speed defense simply cannot stop machine speed attacks. You just can't rely on a security operations center analyst getting an alert, opening a dashboard, and manually revoking a token. By the time that dashboard even loads, your database is already gone. JADEPUFFER succeeded because of a massive structural flaw, leaving real standing master keys and full-power default credentials fully reachable right there in an agent's execution environment. If an attacker, whether human or AI, finds a master key, they instantly inherit the entire blast radius of that key.
Just look at the contrast in reaction windows. Traditional SOCs, operating at human speed, can take hours to respond to threats. They monitor environments where real master keys are just left exposed.
On the flip side, machine speed defense, which is exactly the mission of DevFortress, relies on bounding the blast radius automatically. It uses scoped aliases instead of real keys and enforces sub-2-second automated containment when things go wrong.
So, the crucial point is Section 5, sub-2-second containment and changing the execution context.
We absolutely must change the defensive architecture to operate in milliseconds. The DevFortress solution is built strictly on these publicly stated outcomes. First, never leave a real, full-power key for an agent to find in the first place. Second, change what is actually held in the execution context, meaning replace standing credentials with scoped aliases. Third, provide an automated defense layer that constantly monitors behavior. And fourth, if an agent acts outside its registered scope, trigger sub-2-second containment. You revoke the session and quarantine the agent automatically, without ever waiting on a human.
And this brilliantly illustrates why this 2-second metric is an absolute necessity. Sub-2-second containment is literally the only way to stop a threat that can encrypt your entire Nacos configuration in 31 seconds. Think about it. If your defense takes 3 seconds, you might already be too late.
To put it as clearly as I possibly can, you cannot stop machine speed attacks with human speed defense. JADEPUFFER proved that the old bottleneck is gone for good. If you want to understand exactly how to secure your infrastructure against these agentic threats, you need to grab the DevFortress Master Edition textbook over at devfortress.net. It explains exactly how to bound the blast radius automatically.
I want to end this explainer on a high-stakes reality check. I want you to look at your own architecture. Look at exactly where your keys are stored right now. If an autonomous AI agent hijacks your environment today, can your human speed defense actually stop it in under 31 seconds? Because if the answer is no, well, your entire production database is already living on borrowed time.